So in this video today, we're going to go over two-way tables and conditional probability. Yesterday, we talked about two-way frequency tables, or two-way tables in general, that they're useful ways to organize data that can be categorized by two variables. But we didn't really talk about joint frequency, which are cell values in a joint frequency table. So that's all the blue. Y'all see that? That's like all the data that you put into the table. And then there's marginal frequency, and those are the total numbers of specific response given. So basically the totals down here, like participates only in sports at Archer, and then participates in clubs, and then both, and then participates in neither. Okay, so if you're given that a student, so we're going to use this table to then basically find the probability. If you're given, new word. We haven't seen that word before, if you're given. Okay, so this is really important, guys. If it says given, then we're going to approach the problems a little bit differently. It says if you're given that a student participates in only sports, what is the probability they are a male? So when it says given and it says participates only in sports, then we are going to look at those that participate only in sports, and we're going to pull the total. And that's what's going to go in the bottom. So this number, our total that participate in sports, I'm just going to abbreviate it, okay? That's going to go in our denominator, okay? And then it asks us, what is the probability that they are male, okay? So of those people who participate in sports at Archer, how many of them were male? So there's your other number. So then we're going to talk about males that participate in sports, right? Okay, so this means we're going to put our 4 over our 9. That cannot be reduced, right? And we do 4 divided by 9. Sorry, that doesn't look much like a 9. That's going to be equal to 0.44, which is 44%, okay? Letter B down here says if you are given that a student is female, okay, now we're given that a student's female, okay? So, again, we're going to look at the total females. That's our given again, see that? Female, okay? So that means we're going to put our 32 in the denominator, okay? Because that's our total females up here. See our total females right there, 32, okay? And then it says, what is the probability that they participate in both clubs and sports? So how many of the females participate in both sports and clubs? That would be 11, right? So that's going to be 11 over 32, okay? So that cannot be reduced either, and that's 0.34, which would be equal to 34%, okay? So that given word, key, okay? All right, so the next one says a sociologist collected data on the types of pets in 100 randomly selected households and summarized the results in a table. So what we want to do now is we're going to actually, excuse me, we're going to add up these totals. So we're going to create a total column here. We're going to create a total column here, okay? We're going to do that first. So 15 plus 18 is 33. 24 plus 43 is 67, okay? Then we're going to add the 15 to the 24. That's going to give us 39. And then we're going to do 18 plus 43. That's 61. Okay, so then our total down here would be the 100. And that's how we check to make sure that we have the right values. Okay, so to find these marginal and joint relative frequencies, we're going to divide those numbers by our total. So we're going to do, for this one, we're going to do 15 divided by 100. And that would be equal to 0.15, right? Same thing with the rest, okay? So we're going to do 24 divided by 100. That would be equal to 0.24. 39 divided by 100 is going to be 0.39, okay? You'll see what we're doing? Again, 18 divided by 100, that's going to be 0.18. Same thing with 43. 43 divided by 100, 0.43. And then this is going to be 0.61. Y'all see in the pattern here? This is going to be 0.33. This is going to be 0.67. And then if we were to add up all these numbers, what would we get? We'd get our 1 out here, okay? So now that we have our table of joint and marginal relative frequencies, okay, then what we're going to do is we're going to use that to answer this question. If you are given that a household has a dog, okay, so how many dogs total are in the household? This is our given, okay, so we're going to look at what? Owns a dog, yes, okay, so we're looking at this area right here, right? Owns a dog, okay, so we're going to put that 0.39 on the bottom, okay, and then what is the other part of this? It says also owns a cat, so which one's owned a cat? So wouldn't that be this right here? Okay, so that means we're going to put that 0.15 on top, right? So we're going to divide the 0.15 by the 0.39, and that is 0.38, which is 38%. Okay, so again, when you get that given, what we're going to do is that's going to tell us what our totals are. Okay, that's going to go in the denominator, and then the other piece is going to go in the numerator. Make sense? Okay. So this next one says comparing conditional probabilities. Thomas is trying to decide the best possible route to drive to work. He has a choice of 3 possible routes on each day. He randomly selects a route to keep track of whether he is late. After 40 days trial, his notes look like this, okay? So then it says use conditional probability to determine the best route for Thomas to take to work. So on this one, what we're going to do is we're going to break this up into A, B, and C, okay? A, route B, and route C, okay? So what we want to do is take the times he's not late over the total, okay? So the times he's not late is 10, and our total is 14, right? So that reduces to be 5 over 7. Sometimes your answer will be written that way, right? That's also equal to 0.71, which is what? 71%, right? So 71% of the time he wouldn't be late. Okay, so now let's do our B. This one is 7 over 7 plus 3 is 10. So that doesn't reduce, right? So that's just, and so then let's go ahead and write that as that's going to be 0.7, which is 70% of the time he wouldn't be late, right? Then our last one is, what is that, 12 over 13, 14, 15, 16. So 12 over 16, that does reduce because 4 goes into both of those. So that's 3/4, isn't it? So that's going to be 0.75, which is 75% of the time he wouldn't be late. So then it says use conditional probability to determine the best route for Thomas to take to work. Obviously, that would be what? The 75%. Okay, so that would be route C. Got it? So this next one is conditional probability formula, and this is on your formula sheet. So basically, this is saying what is the probability that A occurs given that B has already occurred. So here's the net with this, y'all. So what we're looking for is we're going to put whatever is the and statement on top and whatever is a single statement on the bottom, okay? So when you're reading your words, okay, you're going to look for, wow, I cannot spell single, y'all. We're going to look for this statement that has an and. So if it says 70% of your friends like chocolate, so we're going to put 70% here. And 35 like chocolate and strawberry. See that right there? What is the percent of those that like chocolate that also like strawberry? Okay, to find this now. So that's basically saying what's the probability that given those who like chocolate also like strawberry. Okay, so what does that mean? So then we're going to put our and statement. So that means we're going to put our 0.35 over our 0.7. We're going to change these to percentage or to decimals. Okay, and when we do that, we get 0.5, which is equal to 50%. Okay, so remember, you're going to put the and statement on top. There's where your and is, and you're going to put your individual one on the bottom. Now, sometimes it'll give you probability of A and probability of B separate, and you're going to have to determine which one you want to put in the bottom, and that's going to be based on the given information again. Okay? So now, down here, we're going to do this with the table. It says male and female students were asked to choose if they could a superpower. The two-way table shows the results from the survey. Use the table to answer the following questions. So this is saying, what is the probability that of invisibility given that the person's a female? Okay, so now listen again. This is our given part. The second part is always our given part. Okay, so given that the person is a female, how many total females do we have? That's what we're looking at. Okay, so we're going to say this is female on the bottom. Y'all got me? And then females that are what? Females that chose invisibility on top. Okay? Okay. So how many total females do we have? 228. See it right here? Okay. And then how many of those chose invisibility? 48 of those, right? So again, if this can be simplified, we're going to. And it can. So that's 4/19. And that's equal to 0.21, which is 21%. Okay? So this next one says males given freeze time. Okay? So once again, think this through. The second value is what you're going to put the total of on the bottom. So where's our freeze time total? Right there. So we're going to do 131, and then we're going to do the males that chose freeze time, right? So it's going to be 71. See it? 71 over 131. And this time that is 0.54, which is 54%. Okay? The next one says, what is the probability of choosing a female given that she chose telepathy as her superpower? So here's your given. It's this time telepathy. See it? So there's your telepathy. Okay, so that's going to be our 118 on the bottom. And then it says choosing a female. So there's our females. Okay, so that's going to be 70 over the 118, right? That reduces to be 35 over 59, which is 0.59, which is 59%. Okay?